Looks like it's live. We good? think we're good. Okay, let's go post this out real quick. Okay. All right. Okay, so let's get started here. So I got Ollama installed. We're at least installed. So let's okay. So let's go install a model. So Llama whole Llama 2. Let's just do Llama 2. Okay. 3.8 gigabytes. That's not too bad. Kind of honestly expected more. Well, it does that. I probably want to. Oh, yeah. CD. Local. All right. Is it done yet? 21, 22%. Okay. So let's create, because I want to play with the API, because there's like a whole API element to this. So let's do the test HTTP. Oh, I think my NVIM. I haven't used NeoVim on Windows in a long time. I think I need to local. Yeah, I think I see. I think I switched to LazyVim since this has been used. I think I gotta delete some stuff before NeoVim's even gonna run. Oh no. Oh no. Oh, it's probably downloading LazyVim is what it's doing. It's probably why it's gonna take a second. Ooh, look at that. Failure when receiving data from peer. Interesting. Why so angry? Okay. Something's... Still thinking. It's using... Wow. It's using like 40% of my CPU. It's crazy. What is my... Let me go look at something real quick. Did I change my power plan before I started this? No. There we go. That'll probably help. High performance. We're gonna need it for the LLM stuff. 3.4 downloaded. I should have updated NeoVim beforehand. Or my NeoVim config beforehand. It's completely untested on my Windows box. Yeah, that doesn't look good. What do we got in here? Plugin. Yeah, remove, packer, compiled. We gotta go in here. I think packer stores it, yeah. Move that. Okay. The lazy lock file changed. Okay. Let's quit that. Let's try this again. And I think my status bar is broken. Okay, our LLM is downloaded. Okay, so lazy. Looks like lazy. Yeah, okay. So it's broken on Windows 2. Lua line's broken on Windows 2. Neat. I should file an issue for that. We're trying to fix it. Oh, and then Tree Sitter's got to do its thing. Hopefully that doesn't fail. I think I've got Zig installed, so it should work. Hey, Tree Sitter works. Cool. Okay, cool. So we'll be able to make API calls here locally. Okay, Ollama list. Okay, we've got Llama 2, Ollama run. Actually, let's show llama 2. What does the license look like for this? Did they say no? What license is this? It's its own license. Can you... I thought there were some weird things around this license. Okay, as is, limits of liability, that's standard stuff. You must use it responsibly. Okay, so you cannot do nuclear warfare with this LLM. Cool. That sounds fair to me, I guess. Or use it for drugs or guns. Okay. Harm others. Okay. Okay, I didn't see anything on commercial use of this model. That was what I was curious of. Can you integrate this into a commercial product? Collectively meta proprietary Llama 2 and documentation made available under this agreement. Okay. So it doesn't really... It doesn't talk about the things that it creates. So in theory, based on my current cursory glances, it looks like you can probably do things with it, even if you don't. I mean, you can do commercial things with it. I might have to look that up. Let's do that. Let's just double check this to be sure. That's the wrong browser. I should have double checked that beforehand. Which one? Which one? There we go. Okay, so can you use Llama 2 for commercial use? Free for commercial use and research. Cool. That's neat. That's pretty neat. Okay. Okay. Let's see here. So let's just run it. Let's Ollama run Llama 2. What I'm really curious is will it use my GPU for inference? That's why I'm on Windows right now. I would like to see it use one of my 2 GPUs for inference here. So let's say oh, that's fast. That's really fast. That's like faster than ChatGPT. Okay. I'm just an AI. I don't have feelings or emotions, whatever. Okay. Generate me a hello world in assembly. Make it compatible with the NASM. Wow, this thing is fast. Okay, I saw spikes on both GPUs. It's using both. So I have an RTX 2080 Ti and a GTX 1060. And I saw spikes in usage on both of those when I made that question. So it's using multiple GPUs for inference, which is impressive. I didn't have to do anything to my machine to have that just work, and now it's responding really fast, like faster than ChatGPT or Anthropic, like Claude. It's pretty impressive, or like Copilot. You could probably. Oh, I did. I thought of this, but someone on Twitter said that you can also do like Copilot style stuff with it. There's a project to do that, but it only shows up as like a VS Code extension, so I don't know how helpful that's gonna be for me. I might have to give it a shot just to see how that works. But yeah, this is cool. This was easy, and it has an API too. We'll get into that. We'll get into that later. Let's see. Me a JSON. Yeah. Okay. So generate me a JSON, me some JSON test data. I would like it to be of students and classes at a university where students. Okay. Resource wise, it's not using all of the GPU. It's using a fair bit of it. It's using like no CPU to do this. 4 classes, with each student having 1 or 2 classes associated with them, and each class having a teacher assigned to it. You can modify this data as needed to fit your use case. What do we got here? So we got our classes, and then we got our students. Okay. So it gave us 2 students. Okay, let's can you please provide at least 20 students and 4 more classes? So it gave 4, so we're asking for 8 classes. We'll see if it understands. Oh, it's chugging. Oh, there was a spike up to 100 on the 1060. So if you were running this at scale, like what OpenAI is doing with ChatGPT and Microsoft's doing, like, this is a lot of compute. Oh, it didn't understand the prompt. Look at this. So there's 6 here. We were expecting 8. How many students? Oh, it gave us 2. It didn't actually generate us all of it. It's hallucinating. It's hallucinating. It gave us... Oh, and these classes are kind of wonky. Interesting. Instead of being related or nested, they're kind of like... they're just copied. So that's weird. What do we want to ask it? Let's restart our prompt. Let's wipe our prompt. Bye. Why do Thank you. And none of this is using like network at all. Like this is all just running on my local machine. So this makes me wonder if we can. So this makes me wonder. So we have base LLM here, and so that we can hook up things like a lang chain to it, and potentially like can potentially have it we can potentially have it do things like, I wonder if there's like an auto GPT setting for this. So or not setting, but like a project that can hook into this. I also want to know, can you get it browsing the internet? Can you provide that? That'd be interesting. So I've got we've got LangChain docs up so far. Maybe we'll try to get it to like, maybe we can get a book for it to read. Ooh, wait, maybe I wonder if we can provide it something highly technical like the Rust docs, because I mean, I'm not the best Rust developer or anything. I'm not good at it. But I've read the book. And see what it does with that. It'd be really interesting to see if it synthesizes that correctly. So maybe we'll try that. Maybe we can get like the book in like a markdown format and then feed it to LangChain. Or maybe, I mean, maybe we should start small. Maybe we should just feed it like my blog posts, and then ask questions about the things that are in my blog posts. Actually, what? Let's see here. How do you create a plugin for NeoVim? Interesting. Okay. 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 So, I wonder. Call the test. And then okay. Ooh. I know some people had problems getting GPT-4 to do that. Ooh, we could hook it up to an interpreter. We could hook it up to Node and get it to do things, potentially. Get it to like do computations, maybe? I don't know. It's hallucinating this. That's for sure. Or it doesn't understand. It's pumping out some heat. My dog is yelling at me. Why are you yelling at me? What do you need? Wow. Install AstroJS. First, you'll need to install it on your computer. You can do this by cloning the repository or using a package manager. Once installed, you navigate to the directory and run the command astro init to create a new project. Then you can set up your blog. Next, you'll need to set up a blog using a platform like WordPress, Ghost. Yeah, no, I don't think you. It didn't. It doesn't. It doesn't understand at all. So let's see if it knows what that is. Let's see here. So like, let's just ask it, what's astro.js? See, now it seems to know. Wait, whoa. Planetary science anon. Space and planetary. Whoa. Is there another AstroJS? Oh. From who? What is it called? Planetary Science Institute. That exists. Okay, as far as I can tell, it completely hallucinated that. Like, completely. That's kind of crazy. Had no idea. Okay. I'm inclined to like feed it my blog, like all the markdown files in my blog. Like shove those into like how do embeddings work? Ollama embeddings. Let's just do a fundamental. Are embeddings part of the context window of an LLM? RAG LLMs actually does more than just one search for the text. It digs deeper No, this isn't. Well, let's ask it. Let's start a new chat. What are LLM embeddings? Are they part of the context window? Learn vector representations of words and phrases in a language model. Roberta. These vectors are learned based on the input text and corresponding labels during training process. The goal is to capture the meaning and context of words in a way that can be used for various NLP tasks like classification, sentiment analysis, question answering, and more. Embeddings are typically part of a larger context window, which is a fixed size sliding window of input text that the model processes during training. The size of the context window can vary depending on the task and model architecture. Context window is 512 tokens long. So these must be older models. 256. Multi-layer bidirectional transformer encoder, which processes the input text and generates a sequence of hidden states that capture context and meaning of the input text. Interesting. That doesn't really answer my question, though. Okay, it's part of the context. Okay. How much context? Llama to context size. $32K in context length. So I could potentially provide... Huh. Okay. I'm gonna ask it. I'm gonna start asking it things that I know it's not gonna know the answer to and see what it does. Does this person exist? Hi, Wesley.
Hi.
I think it's hallucinating this. Yeah, I think I really do. I think it's hallucinated this person completely. Okay. Yeah, so it's talking about BERT and NLP. So let's can we just... Oh, we can save our session. Ooh. Okay, interesting. Interesting. Hmm. Okay. So let's who is Ben Brower? See, before it hallucinated a person, and this time it's not. That's really weird. Really interesting. That's strange. Okay, let's try to do the... Ah. Okay. Let's try a fresh prompt. This is kind of funny. If you had to guess, it doesn't know. That's funny. Okay. It has no idea. What should we ask it next? Or should we switch models? Who should we play with a different model? Hmm. Maybe let's Ollama. Let's go look. Ollama models. Lava. Okay, so let's do the most popular one. Mistral is the next one. So that's a collection of foundational models. So let's do Mistral. It says it's a 7 billion parameter model, so it should be comparable in size, I would think. Whole Mistral. Okay, this is probably gonna take some time. Let's see. Let's go check out the while it does that. Let's go check out the API. I want to go see specifically on like embeddings how those work. Embeddings from a model. Here's an article about llamas. Additional model parameters. So you're supposed to just generate embeddings from a model. Model name of model to generate embeddings from. Prompt text to generate the embedding. Additional model parameters such as temperature, how long the model will stay loaded into memory following each request. Does that integrate into the model itself? Like, how does this work? How does... Because I'd love to like shove all my notes and my blog into it somehow. Is LangChain the way? So let's maybe this will tell us. So this is LangChain Python, but from LangChain embeddings, import Ollama embeddings. This is a test document. Embeddings. Embed query. So we generate this list of numbers, which is a vector. What are we supposed to do with this vector? Let's load the embeddings class with smaller model. Llama 2 7b. This is a test document. That doesn't... That doesn't seem right. Well, not that it doesn't seem right, but it just seems not helpful. I just don't know. What am I supposed to do with the... How do I... The Data Science Dojo. Demystifying Embeddings 101. Our key building blocks. Yada, yada, yada. Transfer. So LLMs. That snuck up on me. Embeddings. Okay. Continuous vector representation of words or tokens that capture their semantic meanings in a high dimensional space. They allow the model to convert discrete tokens to a format that can be processed by the neural network. LLMs learn embeddings during training to capture relationships between words. Thank you for that. Tokenization is the process of converting a sequence of text into individual words, subwords, or tokens that the model can understand. They use subword algorithms like BPE or WordPiece. Split text in smaller units that capture common and uncommon words. Approach helps to limit the model's vocabulary size while maintaining its ability to represent any text sequence. Attention mechanisms in LLMs allow the model to weigh the importance of different words or phrases by assigning different weights to the tokens. The input sequence. Ugh. Okay. The model can focus on the most relevant information while ignoring less important details. Okay, that's what it's spending its time on. That's attention. That's pre-training. Embeddings are used to represent words as vectors or numbers. Yeah, so we know how to create vectors, which can then be used by the models to understand the meaning of text. They've evolved over time from the simplest one-hot encoding approach. Bag of word embeddings. That sounds... Word to vector embeddings. One hot encoding, simplest approach to embedding words. Term frequency, inverse document frequency, statistical measure. Okay. There's a lot of jargon around. This stuff. I don't feel like that demystified anything for me personally. Just personally. Hey, Bert is a real thing. I didn't hallucinate that. You can generate a vector representation for each company based on its data. The Gen AI step change is that similarity is no longer based on a simple keyword search, but instead on an ontological understanding where similar items are close together in the embedding space. The embeddings themselves can be generated from each company's unstructured text data passed through an LLM. These embeddings, along with traditional structured data, can create a complete picture of a company and allow us to conduct more intelligent searches across your knowledge base. This enables a more accurate and intuitive understanding of similarity across languages, regions, and industries. To leverage the power of your embeddings, you can use them to conduct similarity searches across unstructured text data. Transformed Euclidean distance, which can help find the closest vectors and return relevant results. Are they talking about vector databases essentially here? Own generative AI Lily uses this approach. How to use embeddings with Ollama. Using LangChain with Ollama and Python. Okay. Yeah, we may give this a shot. We may try this out. Oh, okay. Ask our questions to the actual document using Python. Okay, yeah, we'll do this. We'll do this in a sec. I want to play with Mistral just a little bit here. So let's go do that first. So Ollama run Mistral. Okay. I'm also curious how the performance impact changes. Okay. It's a little more concise. That's nice to see. Here, let me actually people who are see you can actually read what it's saying and it's not behind me. Okay. Can you generate me some sample data? We'll do the same sample data thing. Of 20 students in 10 classes in a university with students being part of classes. Please generate this as JSON. Oh, it included the university. Oh, it's abridging junk. It didn't, so it did, I like the structure of this better, but it didn't include as much sample data as Llama 2, which is interesting to me. I wonder why that is. But I like how the structure like does referential stuff. That's kind of interesting. But it provided like ellipses. It didn't do it. It didn't do it. It still has them in there. Weird. Okay, performance-wise, it's comparable to Llama 2, which makes sense. They're both 7 billion parameter models, so that does make a lot of sense. Let's restart this. Please generate me some sample data. Let's try a fresh prompt. Okay. This looks better. Can you generate me at least 5 more classes with 20 more students? Ooh, it might be doing it. It's a lot less lazy. It seems to be a lot less lazy. Yeah, this looks it's following the prompt, unlike Llama 2. I like it. It did screw up the formatting last time. It did. But yeah, my GPU's toasty. Well, it's actually not that. It's not that hot. It's just the usage is high on both of them. It's just so easy to get set up. I'm still kind of amazed how easy this was. Now there needs to be one for like image generation stuff, if there isn't already. That lets you like pull down stable diffusion and all that stuff. That'd be great. Oh wow. Okay, I wasn't paying attention. Okay, now I'm curious, where is it gonna end? Where's it gonna stop? Whoa. What? Wow. It's just spitting out. This looks like training data. Wow. Okay, I was impressed there for a minute. Now I'm just that's so funny. Wow. This is like a Stack Overflow post or something. What is this? Let's go. Let's go pull that. What's talking about? I don't know. Who? It looks like a Stack Overflow post. It really does. That's just funny. It's got a JS fiddle, but that JS fiddle doesn't exist. It like hallucinated a Stack Overflow post. That's funny. That's incredibly funny. That's not what I wanted. I wanted to clear that. It was distracting me. It just... just spit out some nonsense trying to explain itself. Oh, these things have a way to go. They really do. Okay. So let's do that. Let's do that using LangChain with Python. Let's 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 figure that out. So do I have Python installed? Yes, I do. Okay. So I can say pip install LangChain, I assume. I think it's working. Okay. Are you done? What are you doing here? Python and pip install upgrade pip. Sure, I'll upgrade it. Okay. Okay. So let's go over to. Oh, I could. Yeah. Yeah. Test.py. So what do we here? So let's key that in. So we have from LangChain dot LLMs import Ollama. Actually, so we should probably have a language server first. What? What is... This sounds official. It's not official, but we're gonna install this one. Creating a virtual environment. I just figured we should have an LSP. How to Python. This is all. Yeah, we'll figure that out later. So here I need to say Ollama equals Ollama base URL 11434. Okay. Oh, we need to say model GPT-2, Llama 2. Okay. And then we print, say Ollama dot, yeah. Why is the sky blue? Okay. Okay, and then over here we can just say Python test py. LangChain, importing LLMs from LangChain is deprecated. Please import from LangChain community instead. Okay, so what does that mean? So if I say oh, okay, so say pip install dash u. I don't know what u print LangChain community. So how do you? Oh, okay. It also says that LangChain community. Function call was deprecated. No, okay. Oh, it was slightly different. Interesting. Okay, but it works. Okay, so the next thing that they have us do in the tutorial. So we're gonna just load this. Okay. Mm-hmm. Okay. And then what did it have us do after it's loaded? Loader.load from LangChain dot text splitter import cursive characters text splitter. And then we have after that where it says chunk size, it says 500, and then chunk overlap, oh, it says 0. All splits. Text splitter. Split document data. Documents data. Okay. What next? It's split up, but we have to find relevant splits. And then Submit those to the model. Okay. So it says to do this. And I assume this is gonna be community. We'll just leave that one alone for now. I don't know what chroma is. We'll figure that out. Who is Nelius and who is Nelius's family? Then it says similarity search, question, length, docs. Okay, let's try this out. Okay. Vector stores from lang chain is deprecated. Importing lang chain will no longer. Okay. Document loaders 2. From BS4. Oh. From no module named BS4. Okay. Pip install beautiful soup soup for you can't even see that behind my face. This thing right here. Downloads. Okay. That looks good. Could not import ChromaDB. About ChromaDB, that's a vector database. Interesting. Okay. LangChain must use that behind the scenes. Python packages are so weird. Are we done? Is that it? Are we done? Come on, wake up. Oh, why? Why are we just stuck here? Come on. Ooh, there it went. Finally. Let's try it again. What else does it need? Your system has an unsupported version of SQLite 3. Okay. I guess we're downloading SQLite then, as exhilarating as that is. What? Why would you? And replace the DLL in your Python installations DLLs folder. What is this? Why? Oh, that's so janky. Okay. This is the official Chroma docs. Okay. Can't I just pip install? Let's just try to pip install, okay? PY SQLite 3 binary. Let's just put this right here so that, you know, you can see what I'm doing. What does it say? Could not satisfy PY squeal. Okay. 2 3 binary. Pip install PySQLite 3 binary. Okay, I guess we have to do what the thing says. Great. Okay. Wonderful. Okay, so let's go binaries for Windows x64. Okay. Yeah. We gotta go here, in here. Copy this. I don't like this at all. Where's Python? It used to be here. Python 3.8. DLLs. Paste. Yes, replace. Why can't I replace it? This is NeoVim. Okay. Probably the language server is using it. Where is it? So we gotta close that. Let's try again. Thank you. Okay. Language server didn't blow up. That's a good sign. Oh, no. Wrong command. Oh, it's doing something. Memory bumped. GPUs didn't spin up yet. It's thinking. That's a big book. It's gonna take a minute probably. And it's Python, so it's gonna take a minute. That's just how it works. This is taking a while. Let's close this. I don't need this. Oh, core dump and what is ChromaDB? An embeddings database. Wonder where it's storing this. Can run in memory with no server running. Chroma. That's running a Chroma server. So we would want to run a Chroma server and then connect up the client. First we'd load the data into Chroma and then we'd load it. We'd pull all the stuff out of it. Interesting. Documents, this is document 1, this is document 2. Metadatas. Can you, how does this? How does this work? Huh. Well, it's still cranking away on it. I'm gonna take a quick break here. I'll be right back. Hello. Is it done yet? No, it's still. I was hoping it was going to be done. I don't know what it's doing. Is it just taking that? It might just be taking that long to load all that stuff into the database, into that vector DB. So it's definitely doing something with the GPUs. They seem to be here. I'll show. They're doing something here. That's more than just my encode on OBS. It doesn't use both GPUs quite that much to do that. So it's processing something on the LLM side of things. So I don't know. If it lasts much longer, I'm gonna probably kill it. But I wonder, and I also wonder where exactly it's getting hung up. Did it actually do the? Is it doing the split documents thing here, or and is it loading here, or is it getting stuck at the similarity search? That's what I want to know. Oh, it said no. I wonder if it's hung up because of that. It's actually okay. We'll do this. Pip install GPT for all. And then we're also going to say print loaded data, and then split data, created vector store. Okay. Oh, we already did that. Okay. What's it gonna say? So it finished up splitting, so it's loading into the vector store. That's what's taking the longest. I don't really want to be like waiting forever for this. Well, we may call it here, and then we can report back with what what this is doing later. So I'm very curious to see if this is gonna work. Might set up a real Chroma DB somewhere, like on my server or something, or even locally, and then have it connect to that, so I'm not doing like persistent in-memory stuff constantly. So let me see if that actually, did that create like a file? No. Interesting. Okay. Very, very interesting. Well, we'll end the stream there, and then we'll see what happens after a while. I'll let this run all afternoon. We'll see where we go. All right. Bye all.